Welcome to our series on radome and bumper testing, where we cover everything you need to know about radome testing and the usage of the powerful QAR50. In this first video, I will introduce you to the basic principles of microwave imaging and the QAR50 in general. You can see the instrument on my left-hand side. So looking at it optically, it looks completely different than the QAR we had in the past. However, we are still using the same technology. That means we are using the same clusters that we are also using in the QPS, our body scanner, and also in the QAR. Instead of using this big panel with a lot of clusters, we are basically reducing it to just 2 clusters. So we have one upper cluster, which is referred to as cluster number 1, and we have the lower cluster, which is referred to as cluster number 2. Therefore, we can perform reflection and also transmission loss measurements using these clusters. So what have we done compared to the QAR? What we basically tried is keep everything that was well received from the customers and improve the points where we see that there's room to actually improve them. So that means we tried to keep the simple operation, make it as easy to operate as possible in order to also have non-RF trained staff being able to operate the instrument and capturing proper measurements. What we have improved is we now have accredited plates. So that means the results that you're getting with the instrument, with the QAR50, are completely traceable in both transmission loss and also reflection, which simplifies the audit process at customers and it comes with the benefit that you get absolute precision and very precise values, and you can verify that the instrument is working correctly. What we have improved, a major disadvantage of the QAR was the relatively low measurement speed. So that means every measurement took about 7 seconds with the old QAR. With the new QAR50, we have improved that. So a measurement now only takes 3 seconds, or with the even improved software, we can get down to 1.5 seconds measurement time. So what are we actually capturing? What are we measuring? So as referred to before, we have 2 clusters. The upper cluster, cluster number 1, and the lower cluster, cluster number 2. So for the transmission loss measurement, we use both the clusters. So we are transmitting a signal with cluster number 1, and we are receiving the signal with cluster number 2. So that means we are capturing all the energy that is going through the sample. As the samples are passive, that means they are reciprocal, and that means that the energy passing through that way is the same energy passing through the other way. So that means we can add up both the measurement results and therefore increase the measurement accuracy that we are getting. So the one-way transmission loss multiplied by 2 in this case is always the two-way transmission loss and the other way around. So for the reflection, we cannot do it that way because some of the samples might be painted or coated. So we actually have to measure both sides separately. So what we are doing then is we are transmitting with the cluster number 1 and we are also receiving with cluster number 1. So similar to the transmission loss, but now we are only using one specific cluster. Then this gives us 2 different reflection images, one for the upper cluster, which is the S11 reflection image, and for the lower cluster, which is the S22 reflection image. So the measurement principle is we are basically capturing a volume, but volumes are super hard to display on 2-dimensional screens. So that means we somehow must reduce the complexity of the data that we captured, and we do so by performing a max hold. So that means for every direction, for example, we are capturing where is the point with the highest reflectivity, and we are just displaying this in the images that we show. The images also have a frequency resolution, so which is here shown on the right-hand side, but the exact interpretation of what exactly is seen in which images, why the images look as they do, and where exactly we capture the frequency response, this is considered in a later video.